Hello everyone, I welcome you for the narrating class for ACD. So in this lecture we will see more examples how we are writing the three address code. So in this lecture I am interested to discuss only to write the three address code and control flow graph. After that each and everyone must be apply the optimization techniques on that control flow graph. Okay, first we will see the example 1. Example 1 is the dot product. If you are considering the dot product, all you know the dot product in the sense. If you have the two vectors, one is the A and one more vector is the B, when these two vectors having the same length, first thing, first element in two vectors multiplied, second element in two vectors multiplied, and so on. The last element in two vectors are multiplied, then those products are summing. What is the value we are getting? That is the dot product result in general. So now observe, we are have the source program for it. Initially production equal to 0, I equal to 1, then this is the do part, and at do part we have the two statements. Production equal to production plus a of I into b of I, and one more is the I value incrementing, I equal to I plus 1. And my condition, how many elements are there? The two vectors, that is the 20, I less than or equal to 20. So now we are trying to write the three address code for it. What about our first statement? Production equal to 0, it is a single, so direct assignment we are considering as a single three address code for it. And what is our second one? I equal to 1, it is also single, we are writing the three address code directly. Now observe, next executable statement is production equal to production plus a of I into b of I. When you are executing this statement, how many operations are there? Plus star, then find the ith index in A array and find that element, 4 operations until now, then find the ith index in the Bth array, 5th operation, find the element under B array, 6th operation. Nothing but we have the 6th operation. Which one is the first we want to be evaluated? In generally, when you are going to be considered the plus and star, first we must have execute the star. So for that purpose, first we must be find the ith index under AR. Whenever you want to be find the ith index, we know the basic rule. How many bytes we are allocating for the I? If you are assuming 64-bit architecture and indexing by default is integer, so that's why 4 into I, that is the first operation. When you are doing the 4 into I, that is not the result, you must be need the one temporary variable t1 equal to 4 into I, that is our third address, third three address code statement. And when you know the ith index, now you want to be retrieve that indexing ith array element, nothing but a of that t1. It is not the full result. Once again you must be need the one more temporary variable to hold the a of I, nothing but a of t1. That is the fourth three address code statement. Then fifth one, once again I into 4 t3, then b of t3 can be assigned for the temporary variable t4. Okay, like t1 is 4 into 1, a of t1, the value can be assigned to the t2, then 4 into I is the t3, b of t3 value can be assigned to the t4. Now observe, so t2 multiplied with t4, good, this is the value we are getting. It is not the once again full result, we want to be stored under one more temporary like t5. Okay, so this t5 is going to be added with production, and once again it can be assigned to the production. If it is different, maybe we are writing the single three address code production plus t5 is the different variable, but right side and left side both having the same variable. That's why you must be write the, don't write under single 3 address code statement. That's why once again you can production plus T5. Okay, it is the one temporary, you can assuming T6. That T6 can be assigned for the production, like T2 plus T in T2 into T4 is the T5, then production plus T5 is the T6, then T6 can be assigned for the production in the same way. So now these do two statements who wrote the 3 address code. Now what is our condition? I less than or equal to 20. When I less than or equal to 20, that condition may be the true or maybe the false based on the I value. So that's why we must be use the if. And our next 3 address code, nothing but 12th one is if I less than or equal to 20, if condition is true, then go to this statement executing. From which 3 address code statement onwards we begin this execution? Third one. So go to of 3. Okay, so this is our 3 address code for it. So this is the source code and this is the 3 address code for it. When we have the 3 address code for it, then find the header statements or leader statements. So we have the 3 rules to find the headers. We know it very well. Already we discussed it in our previous lecture. So by using rule 1, first statement in the 3 address code becoming as the header statement, nothing but 1. That is the rule 1. Rule 2, all our target statements. How many target statements we have, either conditional or unconditional? Only 1. What is that one? 3. So 3 becoming as the header. So by using rule 1, 1, by using rule 2, 3. And by using rule 3, what is our rule 3? After target statement in our 3 address code. What is our target statement? 12th one. My dear, target statement is the 12th, target is the 3. 12th 3 address code, we have the target. After that 13th becoming as the header for us, but there is no 13th 3 address code. So that's why we have the only 2 header statements, 1 and 3. So when we have the 1 and 3, how many basic blocks we have? Only 2. Good. 1 basic block 1 and basic block 2. Under basic block 1, how many instructions are there? 1 and next header before statement. What is our next header in sequence? 3. Before statement is 2, nothing but 1 and 2. Under block 2, from 3 to last, and try to give the flow for these basic blocks. So it is our entry case and block 1 to block 2. What is the block 1 last statement? I equal to 1. It is not any condition, so that's why directly give it. And what is the last statement in your block 2? Block 2 last statement is conditional. If condition is true, where it goes? 3, third in the sense block 2. If condition is true, it repeats the block 2. Otherwise, it is exit, entry and exit. This is the control flow graph. And now we can apply the, each and every member must be apply the optimization method, loop optimization, people optimization, and principal source of optimization. So this is about the example 1. Now we will move to the example 2. Okay, so example 2 is the identity matrix. So this main intention is, we have the 10 by 10 matrix, 1 to 10, 1 to 10, nothing but 10 rows are there, under each and every row 10 columns are there. Initially each and every element can be initialized with a 0.0. After that all diagonals are A of I, nothing but all diagonals are set as 1, nothing but 1.0. And also clearly observe, in the program our index is begin with a 1 and end with a 10. Clearly observe, begins with 1 row, it is the row index, and also the column index, row index and column index. Our column index also begin with a 1. So this is the user's point of nothing but the source code. But now think with respect of the system, it is the user's point of view, imagination. In the user's point of view, the source program are nothing but two-dimensional array is in this form, nothing but rows and columns combination like a table. But in the system's point of view, it does not consider as a two-dimensional view. It can be considered as a contiguous memory allocation, continuous memory allocation, nothing but first row, then second row, then third row, and so on. And also it is the user level index begin with 1 to 10 rows, 10 columns, nothing but total number of elements are 100. So 1 to 100. Okay, and this is the index with respect of machine, nothing but begins with 0. Good, all the architectural indexes are begin with 0 and ends with 99. And what is our row number with respect of user? 1, but with respect of system it is the 0 and it is the 1, and so on, and the last row is the 9th row. 0 to 9 is the 10 rows. Okay, and the columns are also 0 to 9. Next row begins with the 10 and ends with the 19. Next row begins with 20 and ends with the 29. That is the way in generally followed by the machines at the time of execution or storing. Okay, now we are trying to write the 3 address code for it. First, I equal to 1 row and j equal to 1. Now observe, when I am talking about the f ij, nothing but row then column, nothing but the row ends then column begins. So that's why how many elements are there under each and every row? 10. That's why I must have first compute my row into 10. What is the value I am getting? That value can be added with my column number. My column number is given by j. First operation, row number into 10 I am storing in one temporary, and the temporary can be added with my column number. Once again I am storing in my another temporary t2. Like now I am getting which index is that, either 6 or 14 and so on. Which index I am getting, that is now I am getting it. Okay, now it is system's point of in form of addresses, not in form of indexes. Okay. In when you are thinking with respect of address, so we are not bothering about the offset. All the arrays begins with the address 0. Okay, when it is begin with 0, next element starting address is 8. The reason is it is the real number. If you are clearly observe in our code, it is the real number 0.0, nothing but the float if I am assuming. For the integer 4 bytes and float 8 bytes I am assuming. So what is the value I am calculating? Row number into 10 plus j value, I am getting certain value. I am storing under t2. So the t2 can be multiplied with 8 bytes. Then I am getting as the t3. Okay, now observe. Here we are assigned our row value initialized with 1 and column initialized with a 1 once again. But in our computer it must have initialized with a 0. Column also initialized with a 0. So that's why our base address is nothing but, sorry, our starting address is 0. What is the value previously we are getting? That value must have been subtracted itself. Now we can assume your I value is 1 and your j value is 1 according to user's point of view. So first one, I into 10, nothing but 1 into 10, 10 plus what is our j value? 1, nothing but 11. How many bytes are you allocating for each and every element? 8, nothing but 88. What is the value you are getting? What is the value you are getting? That value is not our beginning address. Our beginning address is 0. So that's why what is the value you are getting? That value must be subtracted from the calculated value. Okay, what is our calculated value? 10 into I plus j into 8. From that value must be subtract the 88. So that is the thing we are done it. That is also stored in one temporary. Now we are retrieving that element. That array name is A. So A of 5 or A of 12 or A of 23, A of 40 and so on. So that allocation is given by the particular address is given by the T4. A of T4 is each and every time nothing but all the values initialized with a 0.0. So that's why I am doing it. After then the first element, second element, third element and so on. For that purpose, under that row I must have increment the column. So according to our code, first which value are going to be increased with respect of indexing, either I or j, or in other words with respect of our column must be the inner loop. What is our inner loop? J. Nothing but it must be talking about the column. You must have increment by 1, j equal to j plus 1. After increment, you must have verify the condition. What is our condition? What is the increment I done? J less than or equal to 10, then go to of 3. Why you are saying the 3? If the condition is true, once again we are begin execution of f ij equal to 0.0, from which the 3 address instruction statement we begin that 1 3 onwards. That's why it is go to 3. So after all the columns nothing but 1 to 10, right, executed, but when your j value has 11, then our inner for loop fail. That means columns are over. Then we are going for the row increment. So what is our indexing variable for the row? I. You can increase the I value. I equal to I plus 1. Clearly observe. So row 0, row 1, I am talking about this row. Under row 0 also column begin with 0 to 9, and row 1 also columns are begin with 0 to 9. So that's why I must be, when row increase, the j value must be begin with a 1 only. What is the statement we have? J equal to 1 at 2. So that's why this is the go to of 2. Okay, so this part is over. Now we are going to be write the 3 address code for this part. Nothing but now we are set the diagonals with a 1. So for I equal to 1 to 10, initialized I value is 1. And this is the user's point of view, but in the system point of view its index must be the 0. That's why I am subtracting 1. I minus 1, nothing but 0. So if you are clearly observe, first it must be set as the 1, next this one, next this one. What is the difference? Cells counted 10. 11th one is the beginning address, nothing but 11 into 8, 88. Here also 88 beginning, here also 88 beginning, and so on. So but this beginning address is 0, next beginning address is 88, next beginning address is 176, and so on. So this is my row number according to system, according to machine is the 0. 0 into 88, it is the 1, 1 into 88, next one 176, 2 into 88. So simply I am following that strategy. So what is the system indexing value? That is multiplied with the 88. You are getting certain location. If that location is filled with a 1.0, then you can increment the I value and the condition less than or equal to 10. Then once again you must be go for this one, I value minus 1, nothing but I minus 1 under which statement 30. So go to of 30. Good. So this is the total 3 address code for the identity matrix. How many 3 address code statements we are getting? 17. Now find the leaders for it by using rule 1. What is our by default header statement? First one. Good. By using rule 2, all your target nothing but 3, 2 and 13. Okay, 1 2 3 13. Now by using rule 2 we are getting the 3 headers 2 3 and 13. By using rule 1 only 1. Now I can apply the rule 3. What is our rule 3 in our source program? What are the target statements we have? Target statement number is 9, next one 10 becoming as the header. Here it is the target statement, next one is the 12, and here it is the target next one. There is no 18 3 address code, so that's why these are the header statements for us. How many header statements we are getting? 6. So how many basic blocks we have? 6. So basic block 1 only this one, basic block 2 this one, basic block 3. So 3 to 9. Good. So basic block 4 10 and 12, sorry, 10 and 11, and basic block 5 only 12 itself, and basic block 6 13th to last. So 1 2 3 4 5 and 6. Okay, so this is how we are giving this flow. Observe what is the last statement under our first basic block 1, only 1 itself, so directly goes to the, what is the last statement in the block 2, only 1, so directly goes to, what is the last statement under basic block 3? If j less than or equal to 10, go to of 3. That condition may be true or false. If it is true, go to 3. 3 in the sense basic block 3. So we are giving itself. If condition is not met, go to the continuous basic block 4. What is the basic block 4 last statement? Nothing but the 11th one. If the condition is true, go to 2. Go to 2 in the sense basic block 2. So if condition is true, basic block 2, go to. If it is not, go to the basic block 5. What is the basic block 5 statement? Only 1, we have I equal to 1. So there is no repetition, directly it goes to the block 6. What is the block 6 last statement? 13. What is the 13th block 6? Nothing but if it is the condition is true, block 6 can be repeated itself. So it is a control flow graph. For this flow graph, once again you must be apply all the optimization methods, people optimization, loop optimization, principal source of optimization. This is about the second example. And third example, matrix multiplication. Already you good at a matrix multiplication, and this is the source code for you. All of you try to write the 3 address code for this matrix multiplication. Okay, thank you.